Good evening, friends. Welcome to the session. I would like to recall what we have discussed in the previous session. In the previous session, we had regards to trade analytics. So the specific domain here to understand is trade. And we understood that what are the different applications of machine learning and AI with respect to this domain, that is trade analytics. And what are the different challenges that we have with respect to machine learning or AI, that is for with respect to trade analytics. So now today we'll continue understanding how do you follow the steps for any project management methodology that is followed for machine learning projects. So we need to follow some procedures to understand the data and try to process the data and select the model for based on the business problem, and then evaluate that particular model or whether it is working fine or not. So we can evaluate with the different functions that we have, and also we can discuss with domain experts. So this is also possible. So today we'll see the project management methodology. Before CRISP-MLQ, we had SEMA and KDD. So these two are different, not different methodologies. These are also a part of project management, but there are few slight changes, variations, and it has been updated combiningly to form CRISP-MLQ. What is CRISP-MLQ? Cross industry sorry friends, cross industry standard process. And ML is, we all know that, machine learning, and Q is quality assurance, the quality. So cross industry standard process that we follow for machine learning project, and the different steps that we follow to complete the project. So before this, we just need to understand some of the steps for any domain analytics, any data analytics. You can say, why I'm saying data analytics is because it is with respect to the domain. We have the data and we are dealing it, and we are extracting the insights out of it. We are extracting the insights out of it. So we are telling it data analytics. So these data analytics skill is required, where we have 4 steps. What are the 4 steps? First one is descriptive analytics, next is diagnostic analytics, and next is predictive analytics, next is prescriptive analytics. Now what is descriptive analytics? Descriptive analytics is going to give the history, what happened in the previous. So this description is going to give the from the data. So we need to understand from the data, let it be from 2008 to 2011. So the trades or the shares that has been made is these numbers. Let it be some numbers, and you can just identify this is the data that is related to time, hence we call it as time series data. So as we proceed on the date years 2009, 2010, so the values it is going to change. So we call it as time series data. So for any time series data, we forecast or predict the future. So when I'm predicting or forecasting the future, I just need this step, the history, the past, what happened in the past. So the data gives me the clear picture what has happened in the past. Now after that, we need to diagnose it our analytics. So why we are doing it for forecasting and prediction. Forecasting is also a future prediction. And why we are doing all this, because if some uh, people, those who are investing some amount in the shares or the finance or any capital market, they need to analyze this past history of the company and their shares and the trade transaction. Only then they'll come to know the result and then analyze that and invest in that. So nobody is going to simply put their shares into the market and then get loss. So they'll deeply analyze and get invested in the trading part. So what happened in the past, after knowing this, you just need to test or analyze. When I'm saying analyze, test, we'll say why it has happened. So with the help of why it has happened or the test or the analyze, we'll come to a conclusion or the result. So we'll get the result saying that because of these variations, we got the result. So why it has happened, we have understood. Now we'll predict in future if it comes. In future if it comes, or in future it will happen. Like say example 2008 to 2011. Now what will be the data that can vary from 2001, 2011 to 2012? So here we just need to have a prediction. So what happened in the past, why it has happened, how it will be, how it will be, need to analyze. When there is something prediction when you are doing, so you'll be getting a result saying a prediction. So hence this step is predictive analytics. What is prescriptive analytics? So when you are predicting this, you may get a value and you can evaluate that. When you are evaluating that, you are fine tuning and be in advance prepared. Or I can say the prescription is details to be ready for the future changes. What happened in the past and why it has happened, how it will be, and you just need to be cautious or be ready what to do. So what to do when your prediction is getting some result, you will be ready with what to do. So what if I say you have predicted that 2011 to 12 there will be a rise in the trade market, okay, and you assume that it is you assume and you predicted that it will increase, but somehow it went decreasing. Now what to do in that? So you need to be more cautious and be prepared for both the cases. So you need to have a solution to face the scenario which is other than what you have predicted. So these four steps are important in any analytics, any domain analytics. Okay. So first we'll see what happened in the past. We'll test something and then we'll analyze why it has happened. We'll predict analytics, what will be the next and how it will be. And if you have any variations, you just need to be aware what to do. Okay. So for more trade analytics, you will be having predictions. So for that, the more machine learning algorithms or neural network algorithms methods are used to predict and forecast the data. So hope you are understood. Now under CRISP MLQ, we have a model which is having 6 phases. Earlier we have seen analytical skills. So those skills are required to understand only the data and try to make sure that the data is analyzed and tested. So analytical skills is required when you have this model and then evaluating that model and deploy. So analytical skill is a part of customer. So where it is required for data preparation or data engineering or feature extraction or feature engineering. So you can call as many as need. So CRISP MLQ, the process model describes 6 phases. What is that? Business understanding, data preparation, model building, model evaluation and tuning, deployment, monitoring and maintenance. What is business and understanding, data understanding? When there is a client, you will be getting a problem statement from them and perform activities on that and get the result. So client is expecting the particular solution when there is a problem statement. When they have a problem statement and they are expecting something, they need to provide the data as well as they need to provide the constraints that they have, or the constraints will be given from your side that these kind of data or the problem statement will be having this kind of constraints and you need to take approval from them. So this understanding between the client and the service provider is important. So in MLQ, CRISP MLQ, both business and data understandings are put into the same phase, saying that the business will provide the problem statement with the data and you just need to understand what is data. So data can be of two types, continuous data and discrete data. Continuous data and discrete data. So how do you manage with this continuous data? How do you manage with discrete data? So when you have continuous data as an output, you'll be having a regression model. So when you have a discrete model, discrete with some categorical data, you'll be using classification model. This is when you know the output. When you know the output, you can do with respect to classification model as well as regression model. When you are predicting, when you are estimating, you can also use clustering method. So like this, based on the data what you have and understanding the business, you start working. As soon as you understood the data, you need to perform pre-processing. So data pre-processing. So data pre-processing involves exploratory data analysis. Exploratory data analysis. So this is important portion of today's session because it concentrates on cleaning the data and processing the data, which is important before putting our model, before sending our data to the module. The data given by the client will be in a raw format. Will be in a raw format, and these data need to be analyzed and need to segregate by understanding few things with respect to Python, where you'll be having exploratory data analysis. First, measure of central tendency, and measure of dispersion, skewness, kurtosis, and some graphical representation. So exploratory data analysis is going to have an analysis distributed, whether it is normally distributed, whether it is having any missing value. We'll come to know whether it is normally distributed, and whether it is having any outliers, and whether it is having any missing values, and whether it is having any duplication. So like this, you'll be having cross-verified with the data initially. If you have all this, you have a different methods to follow to avoid this. When it is normally distributed, you need not to worry. When it is not normally distributed, you just need to concentrate on few things to overcome that and make it as a normal distribution. Data preparation. I'm talking about data preparation, that is exploratory data analysis. We call it as EDA. So when there is a outlier, missing values, duplication, we'll do that. Now from raw data, we have something which is as per the problem state, because you'll be having a chunk and you have made clean to get the output. So we have prepared the data in such a way that we'll get some output as per our requirement. Okay. So now at the third step, we'll build the model. The model building, when you are building the model, like we are selecting the model, selecting the suitable model based on the data, either regression model or classification model or uh, clustering model or neural network. So we try to understand the problem statement related with data, and then we select the models. So machine learning models. So after making our data, passing through the model, you'll be getting some output or the result. So these results need to be evaluated, whether it is correct or wrong. Whether it is correct or wrong, we need to evaluate. So model evaluation and tuning. Why tuning is required? If model evaluated as wrong, then we need to arrange something for the different model or fine tune the parameters. So fine tune the parameters that you have in the model and get the output as well as evaluate that. So like this, you have a plenty of models which is working on the data and getting the result, and that will be evaluated. And later it is deployed on the platform and made it as a application, and then monitoring the model. So why we need to monitor? Nowadays, the application that we develop or deploy will be having a source of data from various live stream data. So the data will be live stream, and we just need to make that as a correct format from raw data. But live stream also gives you the raw data. So we need to process that and then give it to the same. So this live streaming data also needs to be monitored and maintained and then given to the model to predict whether it is acceptable or rejected. So we need to maintain the data, live data, which is given to the model. So this 6 steps is also important, and it is part of CRISP-MLQ. So data preparation takes more than 30 to 40% of work, and this is all about 5%, and the model building is taking 20%, and model evaluation and tuning is also taking 20%, and this is considered to be as 5% deploying on some platform, and monitoring and maintenance requires 10%. So 10, 20, 40, 80, 90, okay, 20, 90, 15, 20, 60, 80, 100. So 10, 15, 35, 55, 95, 100. Yeah, this is correct. So the contribution of data preparation takes more time as well as many steps where data cleansing, data filtering, so this is a crisp MLQ. Now what we have after this is each step has been explained here. The business understanding, and when I say business understanding, it is the main goal is to mention the optimization term, that is maximize or minimize. So maximize or minimize. See, when I say trade concept, it is going to have a option like buying and selling. So buying and selling. So the trade with respect to buying will be loser because they are spending the amount of money they're spending. When they are selling, they'll be getting a money and they'll be in a profit. They'll not be spending, or they'll be profit or loss spending and receiving. So they are receiving. So it is receiving from the particular buyer. So he's buying and it is the other way. So the optimization term varies when you are buying or selling the shares. And when you sit and discuss with a client, when the client gives you the problem statement to work on, you'll be maintaining the document. So the document name is referred to be as project charter. And then when you have a document is signed on upon mutual agreement, that is always need to be there. So the project document what you have created need to be signed by both client as well as service provider. So hence the client as well as is more important to have a agreement. Why? Because at the end of the day, if you are understanding the data, you just need to understand whether the data is from primary source or secondary source. So what primary source is all about? The primary source they are getting it from by doing survey or by doing some calculations. Doing survey, doing calculations, and doing some or collecting the data in different Google form. So data, collecting the data from different sources, from Google or from Google Drive or Google Forms. When you create a Google Forms, when it is shared to fill all the details from the other clients or other customers, they'll be updating and you get the collect the data. So we'll be having primary data source and secondary data source. So the client should not come after that and then say to perform primary source of data or to collect the data from various, it will be time consuming. So time consuming, hence we do not want to mention that by client that you are taking more time in collecting the data. If it is already mentioned and the project deadlines should be given, For this, we say that it is SLA. So service level agreement will be given for one of the process of business where you will be having mutual agreement between the client and service provider. So I've told you that data preparation or data engineering, what you call. So exploratory data analysis, we call it as exploratory data analysis, where you need to handle the duplications, outlier analysis, missing values, standardization or normalization, creating a dummy variables, manipulation of string data. So there are more data preparation that is involved to perform the functions. Hence, we use different steps to handle that or to look into that. And later, you will be having a model to work for your problem statement. So, this is the initial stage where a particular data is being given. You just need to cross verify everything. When you haven't seen the right, so when you are able to understand the data, when you are able to understand the data and find the missing values or the outliers or handling the duplications, you need to manage in solving those. Hence you will be having different methodology to perform them. So here measure of central tendency will have mean, median and mode. So how will you create a mean? So mean value will be calculated when you have four objects, 1, 2, 3, 4. So what is the mean value of it? You will be getting 1 plus 2 plus 3 plus 4 divided by 4. So 1 plus 2 plus 3 plus 4 is 4 3 is 7, 7 2 9, 9 1 10. So it becomes 10 by 4. So this becomes like this, and you just need to see to that nothing is missing here. So if something is missing, you can see that if this particular value is missing, you can just update this value. So 437 7310, so 10 by 4. So again I'll be making it as 5 by 2, so it becomes 2.5. So this 2.5 will be updated here in the place of missing value. So this is one of the method to make sure that identify the missing values and then fill that gap. So we call it as imputation technique. So we have imputation techniques to fill the missing values. So measure of dispersion is variance and standard deviation. So we know how to calculate the mean value and then median. So how do you calculate the median value? Let's say example, we have 1, 3, 2, 1, 4, 1 and 3. So like this 1, 3, 2, 1, 4, 1, 3. If you have like this, to calculate the median, we'll just first arrange the values in the ascending order. Sort the values in the ascending order. 1, 3, 2, 1 is also there, and again 1 is there. So we'll be having 4, 3. So 3 should come here. So 2, 3, 3 and 4. So they are having double 1, 2, 3, double 2, 3, 4. So which is having a center one. So when you have a value like 1, 2, 3, 4, 5, which is the center value? So 3 is the center value. So this value will become median. Now when I consider 1, 2, 3, 4, 1, 2, 3, 4, I have taken the mean value as 2.5. So here also median for 1, 2, 3, 4 will be getting 2.5. So median. So this values mean and median value is same. Then you can say that there is no outliers. So you need to analyze the outliers with the help of mean median. You can do it. So when mean is almost equal to median, you will be saying that you don't have outliers. When there is a difference between mean value and the median value, we can say that there is a outlier. So then we have a different methods that will be followed to analyze the outliers. So skewness cutoffs will be used to calculate whether the data is normally distributed or not. So with the help of data, no, with the help of the method skewness and kurtosis, this is graphical representation. Graphical representation. So which gives you information: is there any variance in the data, or is there any deviation in the data, or is there any abnormal or unsymmetrical distribution of the data. So not every time the graphical representation gives you the exact value. So we need some calculations, we need some particular things, hence we go with different models. Not every time the graphical representation will give you the exact value, because when the data is huge, when the data is very huge, then you will face a difficulty in understanding with the help of graphical representation. But if it is through calculations, then it is easy for you to understand, even the data is huge. So we have label encoding. So label encoding to handle the dummy variables. So standardization and normalization will have a different techniques that will be followed. So I told you model building under machine learning. When you are building the model, you have two things. One is supervised and another one is unsupervised. So we also have one more, that is reinforcement learning or Q learning. So this is considered to be as machine learning or AI model. So they are still undergoing with the research that to confirm that whether reinforcement learning is under AI or machine learning. So we have right now we have supervised and unsupervised. So when I say supervised, you'll be having again with respect to when you know the output, when you don't know the output. Supervised, I'm so sorry. Unsupervised means when you know the output. Output is known. When you doesn't know the output, unknown, then we call it as unsupervised. Okay. So when you know the output, if that output is continuous, we'll use regression model. If the if the data is not continuous and it is discrete with some categorical data, then we'll use classification problem. So these are the two different supervised learning model. And when I talk about unsupervised learning model, when the output is not known, we'll form that as a cluster and we'll say that these behaviors are same, the two clusters. So this is showing one behavior and this is showing one behavior. So these two are not same, hence we separate that. So we'll separate as per the number of behaviors that you have from the given data where you doesn't know what could be the output. and we draw the insights from the data and tell that these two are the clusters or three are the clusters or four clusters that is having different behavioral activities. Okay, and we also have model based or data based approach which is having forecasting with the time series. So the trade analytics is all deal with the time, the change variation in the time or the change is going to have a forecasting on this particular data with the help of model based or data based approach. Okay, so only based on data you will get the insights from the for the trade analytics. Now once you got selected with the data, either it is continuous or discrete, whether you are using a regression model or classification model, you will be evaluated by with a, some tool or the method that you will be evaluating. So when you are evaluating, you will say the model is accurate or the model is getting some error. So accuracy plus error is always equal to 1. So error equals to 1 minus accuracy or accuracy equals 1 minus error. So you can calculate either one of them or you can calculate both. So most of the time we'll calculate the accuracy with the help of confusion matrix. When there is a classification model, we'll just use confusion matrix for any accuracy calculation. If the accuracy is not that much, we'll be using regularization technique. We'll use regularization technique if it is not accurately. When I say if it is not accurate, then error will be I. So if you can see that if error is less, if accuracy is less, the error will be high. Let's say example, I'll take 60%. 40% early, it will be error. If it is 60% accuracy, then you will be having 40% accuracy. So if error is accuracy is increased, error also decreases. So based on this, you'll just decide whether the model should be selected or not. And you have the data need to be splitted as train data and test data. So with the given data, when you are splitting as train and test, so the train model, the trained data will be sent to the model and then will be calculated what is the accuracy with how it is accurate. The same test data will be directly passed to the model and get the accuracy. So the train accuracy, the accuracy that is done on the train data should be almost similar to test data because the pattern that is there with the data is also matching with the pattern to the test accuracy. Then you need to confirm that the model is fit. So it is absolutely perfect when the train accuracy is almost equal to test accuracy. When there is a difference, you can say that there exist outliers. Because of outliers, the percentage of the training accuracy is going wrong or testing will be going wrong. The validation is done when there is data which has been missed as part of training that will be considered as a part of validation and it will perform that to check whether the particular data which you have left for calculation as part of performance calculation as part of training data. So this will have better accuracy. The validation will give you better accuracy. So to check for that best performing algorithm, will be using validation on the data. So train data and the validation data to run on the model and then get the prediction. So it also ensures that model neither overfit, underfit. So I've told you that the model is fitted. If there is a variation in the test case, that means you could have asked if the train accuracy is more and test is less. Then I'll say overfitted. If the train accuracy is less and test accuracy is more, then we can say that it is underfitting. It should be same, then we can say it is fitted model. So there are various methods to make that as a fit model and process to work on the data when it is not accurately giving. Now the deployment. Once you are done with your selection model and you are done with evaluating, ML model needs to be integrated with a software system and deploy on the particular platform as an application. For example, when you are deploying a model, that means your predictive functionality will interact with the dashboard and it will have a microkernel software architecture or web-based endpoint in a distributed system. So when I have a ML model, I need to predict something. Let's say example, I have a database and I've given the submission. And from this, I can predict the values by giving the options and get the answer for model prediction. So it is like a web application. You'll be having some interaction to select the data where you have different tools for that to upload the data. It is on without doing any uh, programming skills. You are just uploading the model onto the particular platform, that is web application, and then you are coordinating with JavaScript and the backend program, and then will predict the result after testing the architecture. So once you deploy the machine learning model, we need to evaluate and maintain that because you have deployed in the different platform. Hence, we need to maintain and monitor how it is working and how it is performing. Maintenance will keep track of this. That is what we are doing here. We will be updating and we'll keep on monitoring. So when you are monitoring, you'll monitor the performance of the model as per the change in the data. As per the change in the data. If there is any slight variation in the performance of the data or performance of the model, you just need to give it for retraining. So you'll fine tune or you'll adjust the data or you'll make the data converted to a right format by how it is required, and then we'll deploy and then we'll get the performance of the model. So maintaining that just because the source of data, the source of data keeps on changing. Keeps on changing. The data keeps on changing, and the model performance also varies, goes highs and low. And additionally, we monitor the business use case because it might get changed as we proceed with the change in the data. Hence, you just need to have again the document need to update it with between the uh, client and the service provider based on the business use case. The machine learning model or the task that will be performed need to be adjusted. Okay, so this is the last step that we will be perform under CRISP MLQ. So these are the, I'll quickly recall what are we have discussed. So first we try to understand the analytical stages. So where we have four analytic stages. So data analytics, what are those? Descriptive, diagnostic, predictive, and prescriptive. So coming back to CRISP MLQ, we'll be having business and data understanding. The second one is data pre-processing, or we say that feature engineering, or we call it as exploratory data analysis. So this is an important step that we see under data pre-processing. After that, we'll select the model. We'll select the model, and then once we select the model, when the data is into the model, we'll evaluate the model, and then we'll deploy the model onto the deployment, and then we'll monitor and maintain the. So this is what the CRISP MLQ usually will have. So more concentration on converting the raw data to the required format, and select the appropriate machine learning model and evaluate based on the different accuracy measurement methods, and then deploy on suitable platform, and then monitor and maintain for future predictions. So these are the important things that we have for CRISP MLQ. So what our domain is all about? The domain which we are going to have is trade analytics. So in this, we'll be having capital market analysis or stock price prediction, and analysis of stock market, We can also analyze the import or export a country. So these are some of the things that is with respect to trade analytics. Okay, so we'll see all these are the use cases that we have that will be solved using machine learning model. How we are going to predict the price of the stock and how we in investment. So when you are investing, on what basis, what are criteria that we have to make investment? How do you analyze the stock? Analysis is important with respect to export and import of a country, where it is indirectly helping for a GDP. So these are some of the real time use cases that is helped by machine learning or artificial intelligence. So these are helping us without spending much of the time or cost to get the predictions or to make our decisions. But only thing that you need to spend time to make your raw data which is available and extract the insights out of it. That is the main task that will be performed. After that, suitable model will be selected and you will be evaluating, and then you will be finalizing that is a suitable based on the performance, and you will change the data and then you'll check again and you will monitor and maintain the data model. So this is what important you just need to be aware as a basic before getting into the actual use cases. So from tomorrow onwards, we'll continue with the different different use cases and will perform. We'll just first find important step, that is exploratory data analysis that will be performed, so that you can just be aware how data handling or data pre-processing will be done, so that we can move on directly with model selection and then evaluate that and conclude why this model is appropriate or suitable. So I hope this gives you an idea about CRISP-MLQ and gets you some information out of it. So if you have any questions, we can just discuss, or else we can meet tomorrow in the next session. So good to see that you don't have any questions. So I'm just winding up the session so that we can meet in the next session. Thank you all. Please do subscribe for the platform that we have. We are very actively participating in the platform by updating the interview questions, by updating particular projects that we are doing, and updating the new courses. So you can just keep on updating yourself for the current trend which is required in the global market. You can also go through the uh, we can also go through the 360DigiTMG YouTube channel. Please go through this. You'll be getting more domain analytics sessions. Domain analytics session. So which field you are, and you can just go through that. If you are at a trade, if you are at accounting, if you want to do fraud analytics, if you want to perform some supply chain management, when you want to do some finance analytics, agricultural, marketing, manufacture. There are so many domains that you can link and get the data and select the machine learning model and get the conclusion. So all these analytics domain analytics are there are in the YouTube. So please go through that, like that, comment that, and subscribe it. Thank you all for your patience. We'll see you tomorrow.